In today's lecture, we are going to discuss three important facts regarding a reciprocal lattice. Actually, we will see how we can find the reciprocal lattice to the simple cubic lattice for FCC lattice and BCC lattice. You will see in the discussion that actually the reciprocal lattice of a simple cubic lattice is also a simple cubic lattice, but the cases for FCC and BCC lattices are different. In fact, you will see later on that reciprocal lattice to an FCC lattice is actually a BCC lattice, and the reciprocal lattice to a BCC lattice is an FCC lattice. Actually, this is a very important concept for different type of examinations. Particularly, you can see the previous year questions of civil services examination, where such type of questions has been asked several times. And also in university examination, this fact is asked to you, that so that the reciprocal lattice to a simple cubic lattice is a simple cubic lattice. Reciprocal lattice of an FCC lattice is a BCC lattice, and the reciprocal lattice to a BCC lattice is an FCC lattice. So these are the three very important facts, and we will clearly understand these three facts. And I hope if you will attend the complete video, then all these facts will be clear to you, and you will be able to explain how we can find the reciprocal lattice to a simple cubic lattice, FCC lattice and BCC lattice. Okay. So let us see first of all what will be the reciprocal lattice to a simple cubic lattice. As I have told you that actually the reciprocal lattice to a simple cubic lattice is also a simple cubic lattice. But how you can say this? Let us see the explanation. You can see this figure. Actually, in this figure, I have shown the primitive translation vectors of a direct simple cubic lattice. You know, these A, B, C vectors are the primitive translation vectors of a simple cubic lattice. Okay, and actually if this is a cubic lattice, in fact that means the modulus of A and modulus of B and modulus of C, these will be equal, although directions are mutually perpendicular to one another. So the primitive translation vector of the direct lattice of a simple cubic lattice will be what? This will be in fact A equal to AI, B equal to AJ, because modulus of B is also A, so B is equal to A times J. And C, this is also AK, because modulus of C is also A. Okay. Now, our aim is actually to find the reciprocal lattice to this simple cubic lattice, and for this, first of all, we will find the volume of the unit cell of the simple cubic lattice. And you know, the volume of the unit cell of the cubic lattice will be given by V equal to A dot B cross C. This is the basic formula to find the volume of the unit cell. Okay. Now let us substitute for A, B and C the expression in terms of the unit vectors. You know, A is equal to AI, B equal to AJ and C is equal to AK. Now you know this J cross K, this will be equal to I. So I have written it here I. And this will be I dot I. And this A times A times A, this is AQ. Okay. But you know I dot I is equal to 1. So the volume of the unit cell of this simple cubic lattice is equal to AQ. Okay. Now using the definition which we have learned in the previous lectures, you can easily find the reciprocal lattice vector to this simple cubic lattice. You know, A star is given by 2 pi times B cross C over A dot B cross C. I have used here 2 pi, but as you know, this 2 pi cannot be used at the place of 2 pi. We can simply use 1. That definition is also valid. But here I am following this definition where we use the factor 2 pi in the definition of the reciprocal lattice vectors. So you know, this is the well-known formula for finding the reciprocal lattice vector. A star equal to 2 pi times B cross C over A dot B cross C. Okay. Now, this result will be simplified like this. This is 2 pi. But you know, B is equal to AJ, okay, and C is equal to AK. So instead of B cross C, I have written here AJ cross AK. And you have seen that this volume A dot B cross C of the unit cell of the simple cubic lattice, this is simply A cube, okay. Now, J cross K, this is equal to unit vector I, and there will be A square, and that A square in numerator will cancel out, and as in denominator there is A cube, so there will be A here. So A star is simply equal to 2 pi over A I hat, okay. Now you can find the value of B star. According to definition, you know, this B star is given by 2 pi times C cross A over A dot B cross C. But A dot B cross C is simply equal to A cube. But you know, as this C is equal to what? This is AK and A is AI. And so this will be A square K cross I. But K cross I is equal to J. And A square will cancel out. And then again our result will be 2 pi over A J. And in the similar manner, now you can find the third reciprocal lattice vector C star, and that is defined by 2 pi times A cross B over A cube, okay. And this is 2 pi, but A is AI and B is AJ, so I cross J, you know, this is K, and A square will again cancel out, and our result is 2 pi over A times K. So what you are seeing here, you can see the three reciprocal lattice vectors A star, B star and C star, all are of equal magnitude. That is, the magnitude of A star, B star and C star are 2 pi over A, okay. Although their directions are different, they are directed along the three crystallographic axes X, Y and Z, but the magnitude are equal. So you can easily say that the unit cell of the reciprocal lattice will be also a cube, but age of that cube will be equal to what? That will be 2 pi over A. So after this, you can easily say that the reciprocal lattice to a simple cubic lattice is also a simple cubic lattice. Okay, I think this was a very simple fact, and it is now very clear to you. Okay, so I have mentioned it here. You can see the equation 1 indicate that all the three reciprocal lattice vectors are equal in magnitude, which means that the reciprocal lattice to a simple cubic lattice is also a simple cubic lattice, okay, but with lattice constant equal to 2 pi over A. But if in the definition we will use factor 1 at the place of 2 pi, then our result will be simply 1 over A, okay. So now you can easily say that the reciprocal lattice to a simple cubic lattice is also a simple cubic lattice. Okay, I think this fact has been very clear to you now. Now let us see what will be the reciprocal lattice to a body-centered cubic lattice? In fact, you will see in this discussion that the reciprocal lattice to a body-centered cubic lattice is a face-centered cubic lattice, not a body-centered. And for this, I have shown the primitive translation vector in this simplified figure. Actually, I have not drawn the actual figure here. If you are interested in that actual figure, you may consult your textbook where you will get this. I have drawn only those parts of the actual figure which will be needed to define the primitive translation vector of the body-centered lattice. Okay? And see this figure here. Actually, these are the three crystallographic axes. This is your x-axis, okay? This is your y-axis, and this is your z-axis, okay? So these are the three crystallographic axes. Now, the primitive translation vector of a body-centered cubic lattice. Actually, you know, in case of body-centered cubic lattice, the primitive translation vectors A dashed is directed in this direction. You can see it here. Here there is a lattice point, this is another lattice point, and this is third lattice point. And the distance between this first and second lattice point is actually A dashed. Okay? And similarly, the second primitive translation vector of BCC lattice has been marked here in this figure by this B dashed, okay? And the third one is marked by this C dashed. Now see the figure seriously. Actually, you can see this A dashed has a projection along the x, y, and z direction equal in magnitude. Okay? Actually, projection of this A dashed along x-axis. If you want to find the projection of A dashed along x-axis, you have to draw a perpendicular from the tip point of A dashed here. This line is actually perpendicular to on this axis, and this length, let us say this point is A, then this length is equal to A by 2. This is A by 2. And similarly, when you will draw a perpendicular on this y-axis, then this projection of A dashed will be again A by 2. Okay? And since the projection of A dashed is in z direction is actually in the negative z direction, so this projection will be minus A by 2. Okay? So you can write this primitive translation vector A dashed of the BCC lattice like this. This is A by 2I, okay, plus A by 2J and minus A by 2K. So you can take this A by 2 as a common factor, and this will be A by 2I plus J minus K. Okay? So this is the first primitive translation vector of the BCC lattice. Now see what will be this B dashed. Actually, magnitude of B dashed, A dashed, and C dashed all are equal because this is a cubic lattice. Okay? And again, you can see the figure. The projection or the component of this B dashed along y-axis and z-axis will be positive because its projection will be along the positive z-axis and the positive y-axis. But its projection on x direction is on the negative x direction. So in this case, actually the x projection of b dash will be negative and y and z projection will be positive. And again this can be written as a by 2 and minus I, because projection of b dash along x axis is negative, plus j and plus k. Okay, I think we are getting the facts. Now see, what will be the projections of this third primitive translation vector c dash? Actually, its projection on z axis will be positive because it is in positive z direction, and also on this x axis it is positive, but its projection on y direction is in fact in the negative y direction, so that will be negative. So you can see this c dash will be given by a over 2 I minus j and plus k. So these are the primitive translation vector of the BCC lattice. So now, after knowing the primitive translation vector of a BCC lattice, we can easily find what will be the volume of its unit cell, that is volume of the direct unit cell of this BCC lattice. You can easily find. So let us see. I have actually marked this here, that A prime is this much, B prime is this much, and C prime is this much. But how these have been written, you have clearly understand, as I hope. Okay. Now let us find the volume of the unit cell of this BCC lattice. According to the formula, volume V of its unit cell will be given by A prime dot B prime cross C prime. But as you can see here, that A prime is A over 2 times I plus j minus k. Okay? And dot B cross C. What is B? B cross C, this will be A by 2 times A by 2 times this much cross this much. Okay? So A by 2 times A by 2, this is A square by 4, and this is minus I plus j plus k cross I minus j plus k. But let us find this product. If you will obtain the value of the vector product of these two, you can find it in the determinant form. You know, we will write I, j and k. Okay. Now, the coefficient of I in first vector is minus 1, that of j is 1 and k is also 1, and in second vector it is 1, minus 1 and 1. Now let us evaluate it. Let us take this I as I, and this is 1 into 1, a minus 1 into minus 1. So this will be actually 1 plus 1. Okay, and minus j. Now there will be minus 1 into 1, that is minus 1, and minus 1, minus 1. Okay, and plus k, and this is minus 1 into minus 1, that is 1, and 1 minus, this is minus 1. So this last term will be 0, and this is 2i and plus 2j, minus 1 minus 1 minus 2, and this minus will plus. So this will be simply 2 times I plus j, 2 times I plus j. And so this expression can be simplified as a square by 2 I plus j, because this 2 will cancel out, and here at the place of 4 there will be 2. Okay. Now we will find the scalar product of this I plus j minus k with I plus j. This is very easy. You can see this will be actually a cube over 4. A cube over 4. And take the scalar products. You can see I dot I, that will be 1. And j dot j, that will be 1. And all other terms will be 0. So this 1 plus 1 will be 2, and therefore this is simply a cube by 2. So we find that the volume of the primitive cell of this BCC lattice is equal to a cube divided by 2. You can see the difference. The volume of the unit cell of simple cubic lattice was a cube, but the volume of the unit cell of a body-centered cubic lattice, that is equal to a cube divided by 2. Okay. Now, after getting the value of this volume of unit cell, now from by using the definition of the reciprocal lattice vector, you can easily find what will be the reciprocal lattice translation vectors to this BCC lattice. So according to definition, we can write A star is equal to 2 pi times B dashed cross C dashed over A dashed dot B dashed cross C dashed. Okay. But you have seen that this denominator, which represents the volume of the unit cell, that is a cube by 2. So at the place of this volume, I have written a cube divided by 2. Okay. And 2 pi that is. Now B cross C, actually I have obtained here, you can see this is actually the B cross C, that is B prime cross C prime. And you have seen that this was obtained This was a square by 2 times I plus j. Okay, this was the result. So I have written it here directly, that at the place of B dashed cross C dashed, I have written a square by 2 I plus j. Okay. And after simplification, you can see this a star will be equal to 2 pi over a times I plus j. Okay. Now in the similar manner, you can find the remaining two reciprocal lattice vectors, that is B star and C star. According to definition, again we will write this is 2 pi C prime cross A prime and divided by volume of the unit cell, and that this is a cube by 2. Now again you can find what will be this C prime cross A prime, substituting its value from here. I have not done this product. You can do it yourself. This is just a homework for you, and you will see when you will calculate the value of C prime cross A prime, your result will be actually what? That will be simply 2 pi over A times J plus K. And in the similar manner, you will obtain the value of this C star, and that will be 2 pi times A prime cross B prime over volume of the unit cell, which is A cube by 2. And A prime cross B prime, you can obtain this cross product from here using this expression, and after that you will get that this C star is equal to 2 pi over A times K plus I. So again see, the magnitude of this A star and B star and C star, magnitude of all these three reciprocal lattice vectors are equal. And what will be that magnitude? You can see it here, that this magnitude will be 2 pi over A times root 2. So this is the magnitude, of A star, B star and C star. Since magnitude of all these three reciprocal lattice vectors are equal, and these reciprocal lattice vectors are actually the primitive translation vector of an FCC lattice, and you will see it later when I will define the primitive translation vector of an FCC lattice. Then you will see that actually this A star, which is equal to 2 pi over A I plus j, B star, which is 2 pi over A j plus k, and C star, which is 2 pi over A k plus I. Actually, these are the primitive translation vectors of an FCC lattice. And therefore, you can now easily say that the reciprocal lattice of a BCC lattice is an FCC lattice, because when you have calculated the primitive translation vector for the reciprocal lattice of a BCC lattice, you have obtained the value which is just the primitive translation vector of the FCC lattice. Okay, and that's why we say that the reciprocal lattice to BCC lattice is an FCC lattice. Okay. Now finally we are going to explain that the reciprocal lattice to an FCC lattice is a BCC lattice. Okay, mark it. When you will find the reciprocal lattice of an FCC lattice, the result will be BCC lattice. And for explaining this, again we will find the reciprocal lattice vector in this case, and you will see that the reciprocal lattice vector obtained will be just the primitive translation vector of a BCC lattice. But how? Let us see this explanation. And for this, let us see this figure. I have shown the unit cell of an FCC lattice in this figure. Okay, these are the three crystallographic axes: x-axis, y-axis, and z-axis. Okay, and here you know, as this is the unit cell of an FCC lattice, so at the faces I have marked here the lattice point. This is one of the lattice point at the center of one face. This is at another face, and this is also at a face, center of a face, and this is also at center of a face. Okay, and in this figure you can see this vector which I am just drawing here. You can see this is actually the first primitive translation vector of the FCC lattice, marked by A prime. Okay, and this B prime, this is the second primitive translation vector, and this C prime is its third primitive translation vector. Now you can see how we can express this A prime, B prime, C prime in terms of its rectangular components. You can see it. Actually, it is clear from this figure that this A prime lies in XY plane. See here. Since A prime is in XY plane, so its Z component will be 0, because Z axis is perpendicular to the plane in which this A prime is lying. So A prime will have only two components. One will be the X component, and another will be the Y component. And what will be that? Actually, A prime will be equal to magnitude of A dash. Magnitude of A dash is actually equal to A by 2, okay, and I, plus its projection along Y prime, Y axis is also A by 2, and this is this much. So this is simply A by 2 I plus J, and its Z component is 0, so I have not written it here. Again, see this another primitive translation vector B dashed. See this. This B dashed, you can see, lies in YZ plane. So its X component will be 0. And so B dashed is given by A by 2 and J plus K. Its x component is 0 because this vector lies in YZ plane. Okay. Now, what will be this C dashed? You can see C dashed lies in XZ plane. So its Y component will be 0, and you can write this C prime equal to A over 2 and K plus I. Its Y component. So these are the three primitive translation vectors of an FCC lattice. Now, knowing these A, B dash, C dash, you can now find the volume of the unit cell of the FCC lattice. You can see I have written these primitive translation vectors for an FCC lattice here in this equation 1. And now, volume of the primitive cell. This will be given by A prime dot B prime cross C prime. But A prime, you can see it here, that this is A over 2 I plus J, and dot B prime cross C prime. See it here. The cross product of these two will be what? This will be A square by 4 times J plus K cross K plus I. Now you can easily find what will be this cross product. Without writing it in determinant form, we can directly find it. See, J cross K, this will be I. J cross K is equal to I. Mark it. J cross I, this is minus K. Okay. Now see, K cross K, this will be 0. And K cross I, this is J. So this product will be what? This will be I plus J minus K. Okay? I plus J minus K. And this factor A square by 4 remains at each. And I have actually multiplied this A square by 4 to A by 2, and that will be A cube by 8. Okay? And this is I plus J minus K. Now we will take the scalar product of I plus J with I plus J minus K. And what will be that? Again see directly. I dot I, this is 1. J dot J, this is also 1. And all remaining terms will be 0. In scalar product, you know, when we take the similar product of similar vectors, then that will same unit vector, then that is 1, and when it is different, that will be 0. So this is simply 2. Okay, the scalar product of I plus J with I plus J minus K is 2. And so this will be what? This is A cube by 4. So the volume of the primitive cell of an FCC lattice is equal to A cube by 4. Okay. Now, by using the proper definition of reciprocal lattice vector, you can easily find what will be the primitive translation vector of the reciprocal lattice. Okay. And these are given like this. A star equal to 2 pi B prime cross C prime over A prime dot B prime cross C prime. Okay. But the factor in denominator, this is simply the volume of the unit cell which we have obtained just now. This is A cube by 4. So this is 2 pi over A cube by 4. And you have just obtained the value of B cross C here. B cross C, this is A square by 4 times I plus J minus K. So at the place of this B prime cross C prime, I have written here, you can see, this is A square over 4 times I plus J minus K. Okay. And now simplify it. You can see that this 4 and this 4 will cancel out, A square will cancel out, and our result is A star equal to 2 pi over A times I plus j minus k. Okay. Now in the similar manner, we can find the other two primitive translation vector of the reciprocal lattice, and these are B star and C star. Using their proper definition, you can easily obtain it. B star is equal to what? This is 2 pi times C prime cross A prime over the volume, and that volume is A cube by 4. I have written it directly here. Now you can see this is your C prime, this is your A prime. You can easily find the cross product. This is just, again, I am telling you a homework for you. You can do it, and after doing this, you will get that B star is equal to 2 pi over A times minus I plus j plus k. Okay, and similarly, this C star is equal to 2 pi times A prime cross B prime over the volume A cube by 4, and again finding A dashed cross B dashed, we obtain that this C star is equal to 2 pi over A times I minus j plus k. Okay. Now see these vectors A star, B star and C star. After observing the values of A star, B star and C star, what you are thinking? You can see these are nothing, these are simply the primitive translation vector of the BCC lattice having length of the cube as equal to 2 pi over A. 2 pi over A. And therefore, we can say that the reciprocal lattice to an FCC lattice is actually a BCC lattice. Okay, so I have written it here. You can see these are the primitive translation vectors of BCC lattice having length of cube is 2 pi by A. Hence, the reciprocal lattice to an FCC lattice is a BCC lattice. So now I think this explanation was very simple, and as I have told you earlier, this concept which you have studied today is actually very important for you if you are going to give examination of any type, either university examination or any competitive examination. This concept is very useful to you. Such concepts, the questions on such concepts are asked in short answer type question, or even in long answer type question, okay, or in objective type question. So watch the video seriously, okay, and enjoy. Thank you very much.